So one of the things you want to remember here is that the sign convention is important. So know what a positive velocity means, what a negative velocity means, etc. So remember what your sign convention is. You're technically free to choose what that is. Customarily, we'll say positive equals to the right and negative equals to the left. So what does that look like if we have something like a ball rolling down an incline like we do in this example here? So forget about the rotational motion for a minute. We're just looking at the overall velocity of the ball in the left to right direction. So if I were to, say, make a graph, let's make that horizontal here, of the velocity versus time of this ball, if I released it from rest, then it would start with a velocity of 0, and then as it rolls down the hill, it will pick up speed. It will be moving to the right, so the velocity will be positive and grow larger and larger. So we would have a graph that looks something like this. The acceleration, if you remember, there's a relationship between velocity and acceleration, and graphically, the acceleration is the slope of velocity. So this line has a constant positive slope, so the acceleration will be positive because the ball is accelerating to the right. All right, so what about, let me specify v initial equals 0 here. What about the second case where we have a ball rolling up an incline? So here, it's not going to have an initial velocity of 0, otherwise it wouldn't go anywhere. So let's say we give it some initial velocity up the ramp, and it rolls up the ramp for a while, and then stops and comes back down. What would that look like? All right. So let's think about our graph of velocity versus time. Initially, the ball is going to be rolling to the right. That's the positive direction. So we're going to start somewhere up here. As it rolls up the incline, it's going to slow down and eventually stop. When it stops, the velocity will be 0. So we have to hit the axis somewhere over here. And there's therefore going to be a downward slope. Now, when it hits the top of the ramp, it's going to start rolling back in the other direction. Now it will be rolling to the left, and it will be picking up speed, so the graph will continue on down like this. The acceleration, so ask yourself what that would look like. Again, the acceleration is the slope of the velocity. So this velocity graph is just a straight line with a constant negative slope throughout, so the acceleration is going to be a constant negative value. So notice the acceleration is negative when the ball is rolling up the hill and when the ball is rolling down the hill. The acceleration doesn't change when the ball changes direction, but the velocity does. So this point here, we sometimes call this a turning point because the velocity switches from positive to negative or vice versa. That tells you that the object is changing direction. All right, so just a quick review of that. So one last thing I wanted to talk about a little bit was the kinematic equations. So you have this problem with an astronaut that's throwing a rock up from some cliff on the moon. Let me just talk about, generally speaking, how problems like that would work. So let's say we have some object that is thrown straight up from some initial height, and so we give it some initial velocity, and we want to write some equation that tells us where this ball is at any given point in time. So there are some equations on your formula sheets. One of them tells you the position as a function of time, and it's this long-looking equation here. So you just want to remember what all of these parameters are, right? So this represents the initial position, or I guess in this case you could call it the initial height also. This is your initial velocity, and then this is your acceleration. Now, one thing you want to be careful about here is keeping track of the signs of these values. So you want to make sure you have some defined, established sign convention. So maybe I'll just draw an arrow here with a plus sign, and that tells me that up is the positive direction. That goes for velocity or acceleration. So, if this thing is accelerating due to gravity, remember that that's going to be in the downward direction, so a should have a negative value in this equation. All right. And then back to this equation here, this variable here basically tells us where the object is at the time we're interested in. And then t here and here, this is whatever time we are interested in. So if we want to know where this thing is when we start tracking its motion, we would plug in t equals 0. If we want to know where it is 1 second later, we would plug in t equals 1. 2 seconds later, we would plug in t equals 2, and so on. There's another equation that will tell us how fast this thing is traveling and in what direction. So if we want to know its velocity, that equation looks like this. So the velocity equals the initial velocity. All right, so I think my recording got interrupted there slightly, but hopefully we're still good. All right, so this variable here is the current velocity of the object. This is the initial velocity, and this again is our acceleration. All right, so you want to remember how these equations are used. So the first equation down here, this would be useful if you're given the time and you want to know where the object is located. Equation 2 here, this is useful if you're given the time and you want to know what the velocity of the object is, how fast it's moving or in what direction. But what if you have some other information you're dealing with? What if you want to know, for example, what the velocity of the object is at a specific location? So what if your question is, what's the velocity of this thing when it's 20 meters above the ground? There's actually a third equation we can use for that. And this one hopefully looks somewhat familiar. So this tells us that how to find the velocity of an object if we know its current displacement and its initial velocity. Right, so this would be the current velocity, this would be the initial velocity, and then this here is the displacement of the object. Remember, displacement can be positive or negative. So you take just the current position of the object minus its initial position. So this one can be useful if you're not given the time and you're not asked to solve for the time. Sometimes there are questions that might be solved in 2 or more steps using the other equations, but using equation number 3, you can solve it in a single step. So don't forget about this one. It is on the equation sheet, so just make sure you know when it's appropriate to use that one. All right, so I think that's enough for today. I'll try to continue doing videos like this to sort of review select topics that are relevant to the problems that I currently have you working on. So with that, I will see you back next week.